Today we are going to do a practice session on the concept that how we can implement interrupt in Arduino. Okay. If you look at the screen, you will see a picture. As for example, we have given three different microcontroller: Arduino Uno, Arduino Maker, and ESP8266. This is Arduino Uno, Arduino Mega, and this is ESP8266. Just for example, okay. For Arduino Uno, there are two interrupt pin, interrupt 0 and interrupt 1. You can use pin number 2 and pin number 3. If you need more interrupt pin, okay, these are for the hardware interrupt. Okay. For Mega, you can use pin 2, pin 3, pin 21, pin 20, pin 19, and pin 18. If you use ESP8266, then more pin you can use for the interrupt. Okay. So similar way, for different microcontroller, they have particular pin that you can use for interrupt functionality. Okay. And if you look at the picture, there is a picture of start-stop engine, and there's a motor. Okay, on the right side. So what we are going to do, basically we are going to design a system that will have two buttons. One is the start button and one is the stop button. By using the start button, we will start the engine, and by using the stop button, we will stop the engine. And this will be controlled by the microcontroller Arduino Uno. And we will not use the conventional approach. Okay, that means we will not put our code inside the loop. Instead, we will implement interrupt service routine. Okay, that's asynchronous. That means whenever you press the start button, that interrupt service routine for a start function will be called and the motor will start. When you press the stop button, we will call an interrupt service routine for a stop and the motor will stop. So this will be the efficient way to implement, because you are not keeping the CPU busy looking around your code again and again, wasting valuable CPU resource. Whenever you need to start, just call the interrupt function routine to perform the job. Okay, so let's proceed. We will implement the entire system by Proteus. It is a codeless design. That means by flowchart method, drag and drop method. So let's start Proteus. Right click the Proteus. And run as administrator. So it will open the Proteus simulation software, a very powerful, very mature software from Lab Center Electronics with huge possibility for circuit design, simulation, PCB design. Okay, so this is the interface that is for Proteus Design Suite. We'll click the new flowchart. Okay, if you look at the top, we'll click the new flowchart. So it will initialize the project wizard. I need to give a name of your project. Let's say interrupt in Arduino. I need to give the location. Okay, then click next. Now over here, you need to pick up the right microcontroller, Arduino or Raspberry Pi. So we are doing for Arduino. Then what is the controller? For the Arduino Uno, we are going to design it. And compile is the visual designer for Arduino. I have here. That's fine. So click next button. Again click finish. So it will open up two tabs. Okay, one for the design, other for the flowchart. So this is the design window, and this is the visual designer for the flowchart method. Let's go to the design window. Okay, this is the Arduino Uno. Let me enlarge it a little bit.
Sir, I have a question, sir.
Yes, tell me.
Sir, আজকে তো কুইজ হওয়ার কথা ছিল, এটা কি হবে না স্যার?
So this is the Arduino Uno microcontroller board. So what we are going to do right now, we are going to place the motor driver circuitry. So go to the file menu, import project clip, click Arduino folder and select Arduino motor shield with DC motor. Okay, click this one, click open. So this is the motor shield. Now we'll place two buttons. Okay, one is for start and other for stop. So click for the Arduino button breakout board. So we'll use this button for the start of motor, and need to place another button to stop the motor. Okay, so one for start, another for stop. Now, after placing the components, look at over here. This Arduino microcontroller motor shield with two DC motor, and one button for the start of the motor, another button to stop the motor. Now is the time we need to manually check, because in Arduino designer the connection to the microcontroller pin from the peripheral is automatic. Look at over here. Let me enlarge it. Look at button 1. Button 1 connects to Arduino pin number 2. Okay, this is interrupt 0 pin, and we need to connect button 2 to Arduino pin number 3, that is interrupt 1 pin, because we have seen interrupt 0 and interrupt 1, they are pin number 2 and pin number 3. Okay, so already button 1 is connected to pin number 2, that is interrupt 0. So we need to change this connection to pin number 3. So double click, unlock it, click IO3, lock it. Okay, that's fine. So this is interrupt 0, pin number 2, interrupt 1 for pin number 3. Two button connected to interrupt pin. Now look at over here. We have changed the connection for button 2 to pin number 3. And if you look at the motor shield, this PWMA, this particular pin, pass with modulation pin, they are connected to pin number 3 also to the Arduino Uno. Same connection, overlapping connection, you cannot do it. So we need to change this pin connection for the microcontroller, for the motor shield. Okay, this is the PWM pin. So we need to change it to another PWM pin. So what are the PWM pin of Arduino Uno? Let's find out. Okay, if you look at the diagram of Arduino Uno, this pin number 3 is the PWM pin. Look at over here. Pin number 3 is the PWM pin. 5, 6, 9, 10, 11. So there are 6 PWM pin. Okay, so motor shield is connected to PWM pin 3. So let's change it, because this is 3 pin. From 3, let's change this to 5. I think then our problem will get solved. Okay, because they are similar in nature. Both are PWM pin. Also, you can connect to 3, 6 if you like. Make sure there is no overlapping. Okay, so let's connect, change this pin connection for PWMA. This is for motor A. Unlock it. Instead IO3, connect to IO5. Okay, lock it. So this is also a PWM pin number 5. Now there is no overlapping. Check all the pin connection, find out if there is any overlapping or not. So once you are sure that there is no overlapping pin connection, okay, then you can go for the design coding part. Okay, That means we'll do make our flowchart. So in the setup part, there are two main part, okay, for coding. One is the setup and other is the loop. But in this design, we are not going to use any code inside the loop, okay, because we will use the interrupt function. So in the setup part, let me enlarge it a little bit. To define, it is a CPU function. Enable interrupt, okay. You need to enable the interrupt in pin number 2 and pin number 3 by this CPU function called set the mode of for a specified interrupt, okay. Enable interrupt. So drag and drop enable interrupt pin functionality, and this is object CPU method enable interrupt, and it is interrupt 0, and this is a mode, okay, which mode the interrupt will get triggered. You see, if you get a I think low, change, falling, rising, 4 different way the job can happen. We are going to select rising. Why we are going to select rising? Let me explain. Look at over here. Look at over here. This button is connected to pin number 3. When you press the button, there's a connection for there's short circuit to the ground. From pin number 3, a connection to the ground. That means no. Initially, pin number 3 is grounded. Look at over here. There's a direct connection. It is an open connection. Open connection. Okay. That means this is 5 volt. This is 5 volt. Initially, pin number 3 grounded. Look at over here. Pin number 3 is grounded. When you press the button, a 5 volt. This is 5 volt. Okay. For this power supply, a 5 volt. This 5 volt get applied to the pin number 3. That means initially it is low voltage. When you press the button, it is going to high voltage. So low to high transition. Okay. When you press the button, it is a low to high transition. Initially the pin is low. When you press the button, it is a low to high transition because of this voltage. So we need to trigger the interrupt when voltage changes from low to high at the interrupt pin. Okay, that means on the rising edge. If you do it differently, that means if you do different with the button diagram, that means when you press the button, you supply a high voltage to the, you supply a low voltage to the pin, opposite things. In that case, falling edge you need to choose. So in this case, it's rising edge. Okay, when you press the button, voltage go from low to high. So it is rising edge. So in that case, we need to select rising. Okay. So let's go back over there. So we have done interrupt 0, mode is rising. That means when voltage will go from low to high at that pin, the interrupt 0 will get triggered. Similar way for pin number 3, interrupt 1. Okay, interrupt 1, there the hardware interrupt and rising. The mode is rising. So job is done. We have done the setup. It will just run once. Okay. Our setup part is done. Now there is the loop part. In the loop, we are not going to write anything. Okay. Loop part, we are not going to write anything. Just keep it empty. Keep it empty. We are not going to write anything on the loop. Instead, what we are going to do? We are going to define 2 interrupt service routine, ISR. Okay, interrupt service routine for the start and stop of the motor. So let's do it. drag and drop this block, event block, and give a name for this event. Let's say start motor. And how to start the motor? We need to trigger the functionality at the trigger. Okay, hardware trigger. Get the hardware interrupt, so it's a hardware trigger, and this is a CPU method. Interrupt 0, pin number 2. Okay, so when you press the first button that is connected to pin number 2, it will trigger the interrupt 0, and when the interrupt 0 will get triggered, what will happen? That will be defined in this block. So this is the interrupt service routine. So let's define what to do. We will turn on the motor. Motor 1 will keep on running. Okay, and also another motor will run. Motor 2. Both motor will start. So we have defined one interrupt service routine to start the motor by using button 1, first button. Okay, button 0 or first button. So another for start the motor, another button or another trigger to define the interrupt service routine. So again, drag and drop the event block. Similar way, give a name, stop motor. Stop motor. So how to trigger? Hardware trigger, CPU, interrupt 1. Okay. So in this case, we'll stop the motor. So motor 1 stop. And motor 2 stop. So if you look at over here, in the setup part, we have defined the enable interrupt. Okay, and at which mode the interrupt will get triggered, rising is. Loop function is empty. Two interrupt services we have defined for start the motor and for stop the motor. Okay, let's save it. File, save project. Now run it, simulate it.
কারণ স্যার আমাদের পরীক্ষার আগে যে আপনি ইয়ে করেছিলেন না সেকেন্ড টার্মের পরে তখন টাইগার শেষ হয়ে গেছিল বাকি ছিল আর আচ্ছা দেখো আমাদের হচ্ছে আমরা শর্ট করছি তাই 1 করেছিলাম তাই না দ্যাটস অল 2 করেছিলাম স্যার আমরা শর্ট করছিটা অ্যাকচুয়ালি শর্ট করছিটা একটু করেছিলাম আপনি বলেছিলেন
Okay, press the start button. You see, motor is running. Both motors are running. Press the stop button. Both motors will get stopped. Okay. So press the start button. Motor will start. Press the stop button, motor will stop. So this is the way you can implement interrupt in microcontroller, and it is an efficient way to do some activity where you want to conserve the energy, want to design more efficient system with low power consumption.